Hello everyone, welcome to today's class on matter in our surroundings. Last class we had discussed about boiling point. Boiling point of water is 100. At 1 atmosphere pressure. We also learned about latent heat of vaporization as well as latent heat of fusion. Hope you remember all this. Today we will be considering two questions. The first question is, at what temperature water starts evaporating? The second question we will be considering today is there any difference between evaporation and vaporization? Are they two different terms or do they mean the same? So let us try to understand these two questions. Let us consider these observations. Wet clothes get dried up when you spread them out. We just have to spread them in the open, or do we have to boil or heat it to get wet clothes dried? The answer is no. At room temperature itself, wet clothes get dried up. So, we don't have to heat it at all. Obviously not up to 100 degrees Celsius. The second consideration is, suppose we keep a little water in a beaker and leave it just like that in the room temperature. You will find that the level of water in the beaker decreases. And even if we don't heat it, so we just have to leave it at room temperature, the level will come down. Here again, we don't have to heat it up to 100 degrees Celsius. The third consideration is, if you remember an experiment we had observed in the last class, we started heating a little water taken in a beaker and we observed water vapor at the surface of water before it actually started boiling. So all these observations give us an idea that the evaporation takes place much below the boiling point of water, that is 100 degrees Celsius. So let us try to explain all these questions. And to explain all these questions, let us consider the particles at the surface of water. So we have a little water taken in a beaker and we consider this particle at the surface as well as a particle in the bulk. Bulk means inside. So this particle you can see at the surface. This is surrounded by particles at the bottom, and if you consider a particle in the bulk, so in the first case this particle is at the surface, here it is in the bulk. Bulk means in the inside. Now this particle is surrounded by the water molecules or water particles around it. So you can see out of these two, in which case the attractive force is more. This particle at the surface is surrounded by less number of particles, you can see, whereas for the particle in the bulk, it is surrounded by more number of particles. So obviously attractive force is lesser in the first case, that means in the surface, whereas the attractive force is much higher for the particle in the bulk of the solution. So the particle at the surface can come out in the form of a vapor. It can come out in the form of vapor by breaking all the attractive forces. Whereas for the particle in the bulk of the solution, this will also come out as vapor provided all the attractive forces are broken. So out of these two, in which case we need more temperature? Obviously for the particle in the bulk, you need 100 degrees Celsius, whereas for the particle from the surface, this takes place at any temperature less than 100. So at a room temperature also, this particle can come out. So you can see the first is a surface phenomenon, the second is a bulk phenomenon. And when it is a surface phenomenon, it is called evaporation. And when the particle from the bulk comes out in the form of vapor, it is called vaporization. So for the evaporation to take place, you need any temperature less than 100. For the vaporization to take place, it takes place at boiling point. Now the the wet clothes gets dried up because of evaporation, whereas the boiling takes place because of vaporization, or at the boiling the vaporization takes place. We also know that when the boiling takes place, the temperature remains constant. It takes place at 100 degrees Celsius. Whereas evaporation at temperature less than 100, and the temperature may change during the entire process. So temperature change can take place during this process. So now you know why the evaporation takes place at a lesser temperature, whereas boiling takes place at its boiling point, which is higher. So let us summarize all these differences. You can see the differences between evaporation and vaporization. You can see evaporation is a process. This process takes place at a temperature below its boiling point, whereas vaporization takes place at its boiling point. Evaporation takes place at all temperatures, as you have understood already, whereas vaporization takes place at its boiling point. In evaporation, temperature may change, whereas vaporization temperature does not change. Evaporation is a slow and silent process. Vaporization is a violent process. Evaporation is a surface phenomenon, whereas vaporization is a bulk phenomenon, or it takes place in the entire mass. It's a bulk phenomenon. Now, let us summarize what all things we studied today. We understood the difference between evaporation and vaporization, and all the differences between these two processes. We also understood the difference between the particles at the surface, and particles in the bulk of the solution or of the liquid. Particles at the surface can easily come out, whereas from the bulk you need the boiling temperature. That's all for today's class. See you in the next class. Thank you.